So my name is Krzysztof Sroka, or Chris, and I'm not going to talk to you about internationalization today because mostly of poor planning on my part. Basically, I couldn't prepare a good system for internationalization that I intended to and started some months ago to be ready for this day. So I decided to, instead of presenting to you a half-baked presentation on internationalization, I'll present something that I've already done before, and I think you would like it, and it's about optimization of Flutter apps. It says Fluttering at 60 FPS. It's not necessarily going to be more about visuals and how the rendering happens. It's going to talk about how to write performant Flutter apps, or some practices of writing performant Flutter apps. And 60 FPS is just a token here. So most of the screens we know own both TVs, displays like on this Mac, in my own mobiles have a refresh rate of 60 Hz. So 60 times per second they refresh the screen. There are more advanced, let's say, screens with 120 frames per second or even more. But I'm not going to talk about details, what's better or worse there. I'm going to use this 60 FPS as an example of how Flutter actually tries to achieve this performance. And Flutter sells itself as a very performant engine that you can use to build very smooth apps that actually can render 60 frames per second. And how does it happen on the Flutter side? So basically there are two threads responsible for Flutter's rendering. One is called the UI thread, and this is where our Dart code runs. So all the Flutter framework of our work at widgets, and as developers, basically all we program goes into the framework and the UI thread, and gets run on the UI thread. And the other important thread here is a GPU thread, which is run by the underlying C++ engine. And Skia engine basically takes control over this part. And you normally, and I think no one actually ever does Flutter applications messing with the engine, so we are not going to talk about optimizing that part because it's insane. Unless you want to go to Google and say, well, I have an idea how to optimize your engine more. Go ahead. So every 16 milliseconds, in case of 60 FPS, Flutter basically syncs on an event called vsync. So this is basically synced with the device's refresh rate. And some devices do be more, rather not less than 60 FPS. So it emits an event, and then we start with a framework. So all our Dart code, all our widgets, go through a cycle that I'll explain later. And once this cycle is complete, all of this work of a framework gets shipped into a C++ engine, and on a GPU thread the engine does the magical work. And if it fits into 16 milliseconds, both of these executions, then we are home. We will have between every vsync event one frame rendered from our application to the C++ engine and displayed on the screen. There's an alternative there. So let's say we are a little bit non-performant. However, we still fit, each framework cycle still fits into 16 milliseconds. Framework will always start executing if there's no other framework cycle going on at the vsync event being emitted. But the engine will start immediately after the framework is done. So if we actually fit the framework work within 16 milliseconds, we will still have 60 FPS, just with tiny bit of latency. Now, of course, we would rather have a first case, but before I get to techniques on how to actually achieve that, we need to take a look how Flutter actually does its work. There's a common misconception that Flutter is all widgets. And this is written in some documents of Flutter, and there's like a common saying, it's all widgets, and there's a podcast like this. Flutter is not all widgets. So what we write is mostly widgets, but often we deal with elements. And the difference between them is widgets are sort of a blueprint, or they are often referred in the documentation as a configuration. And basically they are not really one-on-one mapping to instance of, let's say, our layout on a screen. What widgets map to is elements, and every widget that we write is mapped to a single element. Elements themselves are the basic building blocks of the Flutter framework. So Flutter actually doesn't deal with widgets themselves. Where the Flutter framework works, it works on elements. And it's not only widgets and elements, because there are also render objects. Render objects are actually the classes that perform painting and actual visual application of what we write in widgets. And you can maybe see, I think it's well visible here, that not every widgeted element has a render object. Plenty of widgets that we write as a programmers when we extend stateful widgets and stateless widgets do not map to any render object themselves. They basically compose other widgets, and unless we actually write, we can write something called render object widget and other subclasses of render object widget. Widgets won't map to any render object. They will be basically composing other widgets which themselves might map to this. So we have three layers to this. So as I said, the stateful widgets, stateless widgets, which we mostly deal with, as well as inherited widgets, they all map to some subclass of component element which doesn't have a render object. But there are also render object widgets, and many of the classes in the Material Cupertino library, on the widget libraries that Flutter gives us, are actually render object widgets that map to some render object eventually, which does the painting. So we have on the left side the widgets, which are configuration, some instantiation of these widgets as elements, and on the right side render objects which draw everything. So there are more trees actually than this. There's also semantics tree, focus tree, kind of interleaved, but we won't focus on them because they are kind of secondary. What's important is that these render objects are quite expensive, and we try to avoid doing work on render objects because each of these actually maps to some work of the engine. So whatever we do with render objects is going to... Sorry for that. Uh-oh. There's no more recording. Yes, so render objects actually will draw something, and they will give more work to the C++ engine underneath. And we try to avoid doing a lot of render object things, and I'll also show later how to do that. But lots of the work that framework does, and where the speed can be, is that we actually, when writing widgets, we think of them as some kind of hierarchy with configuration, and we change this configuration. We replace text with other text. We click a button and the counter goes up or down. And what happens then is basically the elements that Flutter has created go into this crazy cycle of first, if there are no elements with some widget, they get mounted to the tree of our elements, and then they undergo the frequent cycle of building and marking to be built. So basically, they are marked as dirty, and they are rebuilt at every vsync of our application, of our framework's work. Until, of course, they get unmounted. So if we dispose of some widget, we change the screen, pop some widgets, close the app, they get unmounted. Now, fortunately, Flutter is a little bit smart on this, so it doesn't do everything synchronously. Like if we say, if some widget rebuilds, it basically puts it on a queue of widgets. If some widget is marked to be dirty, it gets put on a queue, and all the widgets that are dirty get rebuilt together at a later time. And what happens there is we have a nice element that gets rebuilt. So it is dirty, and the framework says, well, let's rebuild it so it's not dirty anymore. It then tries to update the children of this element. So as we have widgets and its children, elements have also appropriate children that get updated. And this is the most expensive thing that happens on the framework side. But this is something we want to limit. Because eventually, if we did if we had least optimized app, we would have a rebuild at the root level, and the whole every single widget and every single element would undergo this cycle, and this is actually quite a lot. We want to avoid this because Flutter is quite smart about reusing elements. So Flutter has these elements that are actually mapped to some render objects sometimes, but are some instances of what we see on a screen. And when we change, for example, a text in our widget, Flutter can reuse the same element. And this is what happens when we do update. But Flutter cannot do everything, and it has certain heuristics of what it does. For example, if it tries to update a widget, so we have, for example, a text called alpha and the other text called beta. There are two widgets. If they would be the same instance, it's all clear. We don't actually need to rebuild anything. We return a child because the only place that this actually happens is where we use a const widgets, which are compile time constants. So when we basically have a same configuration, compile time configuration, we don't actually need to rebuild anything because Flutter handles that differently. This doesn't mean that these widgets cannot change, they change just different way. But when we actually rebuild our tree, this is a best case scenario. So we have const widgets, and we don't need to update the whole trees underneath them. The next thing is that if we there's this function widget can update, which compares to configurations. So we have two texts, as I said before, or two widgets that get compared in versions. And basically this means if they have the same type and if they have the same key property, they can get replaced. So instead of creating a new element, which is another instance, and it causes sometimes a new render object to be created, and that causes another paint, which I'll go to later. This child can get its widget basically replaced. The element remains the same, but the configuration of that element gets updated, and there's a function called didUpdate widget, for example, in stateful widgets, in states actually of stateful widgets, which basically reacts to this. So the configuration changes, and sometimes we could have bugs because of this. But I won't get into details of why the bugs are there. But yeah, the widgets can change, for example, but the state remains the same. And this is quite a good thing because we don't need to recreate the whole element tree. The third case is that there is a global key. So global key is this nice hatch of replacing the whole structures of our application. And it could be used if we have, for example, screens that get moved in our application, but yeah, they are maybe quite heavy. For example, they contain images that are rendered or some that are rendered. This is expensive actually operation to render some images. We don't want to do. We don't want to redraw, for example, an image, so we give it a global key. But this is a corner case. It's more here to just be for completeness. And if none of these cases happen, so for example, we replace a text widget with the icon widget. They don't have the same key. They don't have the same type. Or we use key properties on widgets and they don't match. Then Flutter recreates a whole subtree of elements underneath this widget. And this causes all the pain to happen for all this subtree because everything is inflated anew. And this is a worst case scenario, and we try to avoid this by a couple of things. And set state is actually, of course, the thing that causes things to get dirty. So, most of the time. And usually call set state like this, but we need to remember this state is not true. State is just a state object. Whatever we set here, and it's a common misconception, but this has anything to do with state of our widget or something like this. This is basically execution of a function. We could synchronously execute this function, whatever we put to set state, and the actual set state only does these two: executes the function and marks the widget as dirty or element. Okay, that was a little bit, I guess, a lot. I didn't start with saying this might not be for everybody. The first time I gave out, I did this warning. Oh, yes, optimization. Never optimize eagerly. Optimization comes with a very, very big warning sign, which is you don't optimize until you need to optimize. And you don't need to optimize sometimes if you, during development, see, oh, my application is sluggish. Many times our application is sluggish because we run in development mode and not in release mode. And release mode has lots of checks disabled. And sometimes rendering suffers because of these checks. So first thing we do, we check that we actually have a problem. If we have a problem, then we start optimizing. So using const, as I said, this is a best case scenario. And const, we usually think like, oh, this is a compile time constant, right? So we have a static text on our side. We have a title of our application, and this is a nice small widget, which can be constant, compiled, and this is not necessarily true. Lots of widgets can be constant, but we need to heavily rely on inherited widgets if we want them to make if we want widgets to be constant. And I'll say a little bit about inherited widgets and how they are useful in optimization. But yeah, other things that basically directly stem from directly caused by what I've said before about how this update works. Don't reassign keys to your widgets. Like, don't dynamically generate new key because you like, I don't know, uniqueness of a key. Keys are there to actually help Flutter match what was previously, or actually not even matched what was previously and what's next. It's for Flutter to say, please do not reuse the previous state and do not optimize this, because I know this is going to change. So it's better to use no keys, and Flutter is quite smart about when you use no keys and, for example, have a column or row or some objects with multiple children, or how to rearrange these widgets. And yeah, use keys rather when you're certain you don't want some cases to be optimized, because that's basically what it's for. Don't introduce changes to the tree. This is important. So when Flutter does this building of new widgets, it goes, of course, through the tree, and it compares what was previously in a tree and what's the new state of a tree, of its elements. And we, for example, have a couple of widgets that we would like to include or not include in a tree. There's, for example, visibility, which hides the widget, basically makes it not paint, or opacity, or some other widgets that are, what we could say these are optional. So what we never do is we don't dynamically introduce or remove them from our widgets tree. Many of them have some booleans saying, am I active, am I actually working? And it's there for the reason that if we change the structure of our widgets, we dynamically remove some widgets from middle of a tree, it all goes to waste, because Flutter will need to recreate everything from the very beginning. So whenever it sees there's some mismatch of the types of widgets or keys of widgets, it just drops everything below. Use global keys if you really need to. So if you have really expensive in terms of rendering widgets, like loading images or drawing vector graphics. But this is really micro optimization, really. And one thing that's very common is to rethink set state. So this set state is actually what causes all these problems. We abuse often set state, because what set state does is, in worst case scenario, it just makes Flutter start with some widget that we call set state on, and replace the whole tree underneath, or rebuild the whole tree underneath. And we try to avoid set state because it's not always necessary. For example, this is a common mistake many people do, that we check for some condition of change within set state. Once we call set state, the widget is going to rebuild. And this is connected to the thing I said before, but that state is a lie. So this has nothing to do with the state. This is just an ordinary function that gets run. Flutter isn't smart about what has changed. Flutter doesn't care about what variable values are. It simply will always rebuild your widget if you call set state. So instead of, like, for example, checking, inside set state, if I have some condition changed, I don't know, something dropped to 0, then I need to rebuild my widget, do of course like this. If a condition changed, then if I really need to rebuild the widget, if I know something has changed, then set state. That's also okay because it's essentially the same. So store your variable somewhere and do comparison, but in larger widgets where you have several values, and several places where you can call set state. This gets really messy if you start doing things like this. So yeah, more like this, occasionally like this. And integrated widgets are another thing that that's very important to optimization, because integrated widgets are there just to optimize things. Instead, so Flutter has this context, right? Flutter has integrated widgets so that we can fetch data from up in a tree. But when we fetch data from up in a tree, we also make an inherited widget know, hey, some element, or yeah, this actually has are elements, not widgets, but let's say some widget below in a tree asked me for my values. So I'll remember when I update, I'll update that widget as well. And this also is one of the examples of why inherited widgets work well, because when Flutter asks for an inherited widget up in a tree, it doesn't actually traverse anything. It has direct map of type of a inherited widget to this instance. So it doesn't need to actually go up the tree, fetch some data. It does so in constant time. Yes, so inherited widgets are really helpful in making sure that instead of set state that would, for example, cause here for full tree to be rebuilt, we rebuild only parts that really depend on the value we care for. But also inherited widgets need to be well structured, because it's easy to depend on inherited widget if we don't need to. So inherited widget, when it rebuilds, when it says, okay, I need to update my children, it doesn't discriminate. It updates all the children that ever asked for its configuration, all the descendants that ask for configuration. So split your inherited widgets, it doesn't cost a thing, really. Have smaller widgets. Use inherited models if you have data that's parameterized, and you can split this data based on some parameter. Oh yeah, but don't split too far. So this applies to inherited widgets, but doesn't apply to some widgets. For example, if we know that there's a widget that's actually creating a render object, we don't want to multiply them. We could say, oh, this is a nice, I'll apply this nice transformation to be clean because I'll have my class set padding left, padding right. And having them separate, of course, creates many render objects, if that widget is a render object, and padding is a render object widget. So instead we use one padding. Note on the container widget, which is frequently used. Container widget is dumb. So container widget has basically inserts padding, margin, alignment, and some other widgets. It's not one nice thing that has a single render object. It's just a shorthand for other things. Oh yeah, explore different threads. So we said what we do in Dart happens on one thread, the UI thread. This isn't necessarily true. There's a very handy function called compute. I don't remember now in which library, but it's one of the standard Dart libraries that can be used to offload heavy work. If you happen to have heavy work done on client side, which maybe you should avoid, but if you need to process some data you fetch from somewhere, and it's a lot of data, then you can use a compute function to actually do that in a different thread. And it's not going to occupy framework time. Once it's done, the future will return, and you'll have some result. Oh, and now to the actual painting. So as I said, we don't want to have lots of render objects because painting is the most expensive thing, and it's really going to, if you have optimization problems, you most likely will have them on GPU thread, because the painting is going to go awry. Not that your structure of widgets is going to be rebuilt so many times, although that could happen, but you hammer the engine so much that it will not be working efficiently. So repaint boundary is a very neat thing, and it's embedded in some of the standard widgets that Flutter has in the SDK. And it avoids a problem that I'll describe now. So let's assume there is a widget that needs to be just repainted. For example, it rotated a little bit. Somewhere low in our widget and render object tree. These are render objects now. Unfortunately, when it does so, and it says I need to actually paint, it will go up, potentially to the root of your tree, and say to all its ancestors and their ancestors, well, you also need to repaint. And when the ancestors do this, they actually go to all the children and cause the whole tree, potentially the whole your application that's visible, to be repainted, even though only this part needed to be. So that's where repaint boundary comes from. Repaint boundary is a widget that basically tags some objects as repaint boundaries. Tags some render objects as repaint boundaries. That means that if a widget if some render object contained in one repaint boundary needs to be repainted, it stops propagating the event up to this certain parent that's border, that's the root of this repaint boundary widget. No. It stops at the nearest repaint boundary widget. Oh yes. And also it doesn't propagate down. So if we have a second repaint boundary widget here, it will also stop propagating down. This is useful when we know that some widgets will have the same layout, will have the same size, basically size, yeah. But they themselves can change. Imagine you have a thumbnail of your photos, and you can press on a photo and does nice animation. It flips around, but it doesn't change the size. Then you can use repaint boundary to actually restrict whatever changes in your app to that little widget. Otherwise, if you don't, and if you're unlucky enough to use some built-in widgets that don't do this automatically, you end up repainting everything in your screen. Oh, this is one note. If you ever meet with this, you probably have optimization problems. So there are some options that you need to read into that can really make your performance suffer. For example, this one is a certain option that's used for creating really smooth layers of widgets. So imagine we have widgets overlapping with each other. With this option, we will have really smooth edges over them, and you won't see that much of the problem sometimes with 1 pixel border in between that you might have found. But if you do that, for example, in animation, this is going to slow your animation, slow your application down really fast. How to get help? So the last part of my presentation is a practical thing. As I mentioned, you don't optimize. So practical tips on what to do when we suspect we have a problem. we first check if a problem exists in a profile mode or release mode. Profile mode is very close to the release mode. It just adds some profiling information to your application, but when running in development, things can get pretty slow. When the problem doesn't exist in profile mode, then it doesn't exist at all. It's a bit annoying because day to day you use debug mode, and if it's slow, it's hard to work with, and you get frustrated and burnt out. But yeah, this problem doesn't exist if it exists only in debug mode. But if it still exists, you can use several options to debug what's happening with my application. One of them is the performance overlay, which on mobile shows you these two nice charts. These charts are the UI thread and the GPU thread. So you notice basically some spikes when either your GPU, or that's the GPU, that's UI, does expensive operations. This can help you in debugging, for example, moments that actually are problematic for your application. Lots of different flags. You sometimes need to basically go to the Flutter source and flip them, or Flutter source, actually flip them by setting the values. Sometimes there are options in the, like here, in the app widget, you can sometimes pass some options like this. There are numerous debug flags like that allow you to actually print what's happening during marking for build and all of the other. These are just selected couple of options. So if you suspect, for example, that you rebuild too much, you would use this flag, set it to true, to see what causes mark as build function to be called. Because this basically will print you, hey, this is a stack. I don't know, I clicked button, or it turns out that you have animation running over time that calls set state, and this will actually show you that this is a problem. A cool thing that's not that much known, but it's really nice, repaint rainbow. So I thought about these repaint boundaries and so on. So if repaint rainbow helps us visualize which widgets get repainted. And it basically draws a border around some containers which will change colors every time the paint is executed on these widgets, or render objects that actually translate to these widgets. Which is really cool thing to see. Like if you think, oh no, I really did well and I only update this single widget to see the whole screen flashing like this. Yeah, oh, there's even animation. But it's really slow. It's not really optimized, but you can see the border has changed a little bit. Yeah. And this is like for hardcore people who really want to dig deep into what's going on, and they maybe are not afraid to even hack the engine. In profile mode, when you start it from command line, and you get this address, which is an inspector for your application. Observatory debugger, that's what it's called, which in profile mode will give you this kind of nice charts. And these charts will help you see this. You actually need to be a bit of hacker of Flutter to understand everything here, but this will basically break down the execution of the functions within your framework and within your engine. For example, you see there's an event called vsync over here, and this is the whole part that the framework takes for re-rendering. And below we have some begin frame, a framework reload engine. And here on the lowest bit we have some stages of basically how Flutter operates. So it does build, layout, paint, see. I don't really know how to see. And you can add your own events to this timeline to debug in more detail what's going on. If you think, of course, this is only applicable to synchronous operations. If you think something is taking a long time, but that's like the very, very last advice. I know it's been hard, but thank you for listening to me. I'm here to answer more questions, and maybe next time actually we'll talk about internationalization, and it will be so much more pleasant. Thank you very much for listening.